At 07:45 a.m. on February 21st, 1945, Electrician's mate second class Joseph Kissel crouched inside the hull of an M4A3 Sherman tank as it rolled toward a Japanese pillbox on Iwo Jima, his hands gripping controls he had personally wired 3 months earlier at Schofield Barracks. The 24-year-old CB from the 117th Naval Construction Battalion had spent 1,200 hours building this weapon, knowing portable flamethrower operators on the island were dying at a 92% casualty rate. 200 yards ahead, a reinforced concrete bunker concealed in volcanic rock held a Japanese Type 92 heavy machine gun that had already killed 11 Marines that morning. The mathematics of death on Iwo Jima were brutal. Every portable flamethrower operator carried 100 pounds of equipment with only 7 seconds of fuel. Japanese snipers identified them instantly by the twin tanks on their backs. They died before reaching their targets. The 19th of February had been D-Day. 70,000 Marines landed on black volcanic beaches. 22,000 Japanese defenders waited in 11 miles of tunnels, 750 fortifications, and countless caves. Naval bombardment had done nothing. Artillery bounced off reinforced positions. Small arms fire was useless against steel doors and concrete 3 feet thick. The Marine Corps needed a solution that could reach fortified positions without exposing men to sniper fire. At Schofield Barracks in Hawaii, Colonel Unmacht of the Chemical Warfare Service assembled a top-secret composite unit in May 1944. 25 Seabees from the 117th Construction Battalion joined Army chemical specialists and Marine tank crews. Their mission was clear: take portable flamethrowers that killed their operators and mount them on tanks. The first attempts failed. Army engineers had created Satan tanks using M3 Stewarts with Canadian Ronson flamethrowers, but these light tanks had limited armor and short range. For Iwo Jima, Unmacht's team located 8 M4A3 Sherman medium tanks. The Seabees, led by machinist mate first class A.A. Rika and Kissel, worked to combine 3 different flame systems. They designed the CBH-1. Installing a CBH-1 required 150 pounds of welding rod and 1,100 electrical connections. Each tank cost $25,000. The system operated at 300 pounds per square inch, sending flame 400 feet with 270 degrees of traverse. Kissel wired every circuit. He tested every connection. He knew if one wire failed, Marines would die. By November 1944, the 8 tanks were ready. The Marine Corps called them Mark 1s. Army documents labeled them POA-CWS-H1. The official designation was M4A3R5. Marines who saw them in action had a simpler name: Zippos. The tanks loaded onto transports in early February. Kissel and shipfitter First Class J.T. Patterson were ordered to accompany them to provide technical support. That meant Hawaii to Iwo Jima. That meant maintenance under fire. Kissel understood what he had built. He also understood no one knew these machines better than their creators. If something broke during battle, Marines would die waiting for repairs. The question was whether this weapon would work. Could the CBH-1 survive combat? Would Marines follow these flame tanks? Could 8 tanks change a battle against 22,000 entrenched defenders? If you want to know whether Kissel's innovation saved thousands of Marines, please hit the like button. It helps more people discover these stories. Subscribe. Back to Kissel. The 8 flame tanks landed on D-Day, but remained unused. Marine commanders were cautious about untested weapons. February 21st was D+2. The assault had stalled. Conventional tanks and infantry could not crack Japanese defenses. 4th Marine Division requested a flame tank for a fortified position that had held for 2 days. Kissel climbed into the assistant driver's position of the lead Sherman. He had built this weapon. Now he would see if it worked. The pillbox ahead had already killed 15 Marines. Japanese gunners inside had clear fields of fire across 200 yards of open ground. No infantry squad had gotten closer than 70 yards before taking casualties. Kissel felt the tank shudder as the driver engaged the transmission. Through the hull he heard incoming mortar fire. This was the moment everything he had built would be tested. The Sherman advanced at 8 miles per hour across volcanic ash and broken rock. Kissel checked the pressure gauge. 300 pounds per square inch. The fuel tanks held 290 gallons of napalm-thickened mixture. The ignition system used a waterproofed cylinder with housed matches that rotated like a revolver. He had tested this mechanism 40 times at Schofield Barracks. It had never failed. At 150 yards from the pillbox, Japanese machine gun fire began hitting the Sherman's armor. The bullets made sharp pinging sounds against steel plate. The tank kept moving. At 100 yards, the driver stopped and pivoted the hull to give Kissel a clear angle on the target. Through the periscope, Kissel saw the concrete bunker's firing slit. A Type 92 machine gun barrel protruded from the opening. Kissel aligned the CBH-1 nozzle and pressed the trigger. The ignition system sparked. Pressurized fuel shot through the nozzle at tremendous velocity. A stream of burning napalm erupted from the Sherman's 75mm gun position and arced toward the pillbox. 400 feet of flame traveled in 3 seconds. The burning mixture hit the concrete bunker and poured through the firing slit. The effect was immediate. Smoke billowed from every opening in the pillbox. The machine gun fell silent. Kissel released the trigger after 5 seconds. The flames stopped. The pillbox burned. No more gunfire came from the position. The Japanese defenders inside were dead. What had taken 4th Marine Division 2 days and 15 casualties to fail at accomplishing, the CBH-1 had achieved in 5 seconds. The Sherman backed away from the position. Marines watching from covered positions began moving forward. One platoon leader radioed battalion headquarters. He reported the pillbox was destroyed. He requested another flame tank immediately. Kissel climbed out of the Sherman once it reached the rally point. Patterson examined the CBH-1 mechanism. All systems had functioned correctly. No electrical failures, no fuel leaks. The pressure gauge still read within operational parameters. The weapon had performed exactly as designed. The two CBs understood what had just happened. The CBH-1 worked in combat. It could destroy fortified positions that conventional weapons could not touch. It protected Marines from the suicidal exposure of portable flamethrowers. The question now was whether 8 tanks could make a difference against the scale of Japanese defenses. That afternoon, 3 more flame tanks went into action. Each destroyed multiple pillboxes and cave entrances. Each mission succeeded without losing a single Marine to sniper fire. By nightfall on February 21st, Marine commanders were requesting flame tanks for every major assault. The problem was simple mathematics. 8 tanks, 4 per division, 750 Japanese fortifications, 11 miles of tunnels. Kissel spent the night maintaining electrical systems and checking fuel lines. He knew the next morning would bring more missions. The flame tanks would be in constant demand. Someone had to keep them operational. He had built these weapons. He would maintain them under fire. What Kissel did not yet know was how the Japanese would respond. Enemy commanders on Iwo Jima had seen what the flame tanks could do. They understood the threat. Orders went out through the tunnel network. Stop the flame tanks. Target them first. Kill the crews. The Japanese recognized these Sherman flame tanks as the most dangerous weapons on the island. On February 22nd, they would do everything possible to destroy them. February 22nd began with concentrated Japanese mortar fire on American tank positions. Enemy observers had marked where the flame tanks refueled and rearmed. At 0600 hours, incoming rounds hit near 2 flame tanks from 5th Marine Division. No direct hits, but the Japanese were adjusting fire. They were learning. Kissel and Patterson worked through the morning maintaining all 8 flame tanks. The CBH-1 systems required constant attention. Electrical connections vibrated loose from the Sherman's movement across rough terrain. Fuel pumps needed inspection after every mission. Ignition cylinders required new match cartridges. The work was dangerous. Refueling operations exposed crews to sniper fire and mortar attacks. Every gallon of napalm mixture had to be hand-pumped into the tank's fuel system. By noon, 4th Marine Division reported their flame tanks had destroyed 18 fortified positions in 3 hours. 5th Division reported similar results. The effect was dramatic. Japanese defenders who had held positions for days abandoned them when flame tanks approached. Marines advancing behind the Shermans encountered less resistance. Casualties dropped. Progress accelerated. But the demand was overwhelming. Each tank battalion had only 4 flame tanks. They operated from pooled locations, dispatched to wherever the assault stalled. Radio requests came constantly. 1st Battalion needed a flame tank at Hill Peter. 2nd Battalion needed 2 at a cave complex. 3rd Battalion had a fortified ridge they could not advance past. The 8 tanks could not be everywhere. Marine infantry officers began refusing to advance without flame tank support. They had seen what these weapons could do. They knew conventional attacks meant high casualties against fortified positions. The flame tanks saved lives. Marines would wait hours for a flame tank rather than assault without one. Kissel saw this firsthand on February 23rd. A company from 23rd Marines had been pinned down for 6 hours by a cave complex in the northern sector. The Japanese position held 3 connected caves with interlocking fields of fire. Every approach was covered. Artillery had been ineffective. Infantry assaults had failed. 12 Marines were already casualties. Kissel accompanied the flame tank dispatched to the position. He rode in the assistant driver's seat, monitoring the CBH-1 electrical systems. The Sherman approached the cave complex from an angle that limited exposure to enemy fire. At 75 yards, the gunner opened fire with the main flame weapon. The first burst sent 400 feet of burning napalm into the primary cave entrance. 5 seconds. The gunner shifted aim to the second cave. Another 5-second burst. Then the third cave. The 3 caves became infernos. Smoke poured from interconnected tunnels. Secondary explosions erupted as stored ammunition cooked off from the heat. The entire complex was compromised. Marines advanced and secured the position without additional casualties. That single mission took 11 minutes and used 60 gallons of fuel. What would have cost the 23rd Marines potentially dozens of casualties and hours of fighting was resolved in less time than it took to brief the assault plan. The Marine Company commander radioed a simple message to battalion: "Send more flame tanks." But there were no more. All 8 were committed. Requests were stacking up. Japanese defenses stretched for miles. The flame tanks were working exactly as designed. The problem was, there were not enough of them. By February 25th, the 8 flame tanks had been in continuous operation for 4 days. Kissel had worked 18-hour shifts maintaining them. Each tank averaged 4 to 6 missions per day. Fuel consumption reached 5,000 gallons daily. The Seabees at the beach supply depot worked around the clock mixing napalm and pumping it into jerry cans for transport forward. The CBH-1 systems were holding up better than expected, but problems emerged. Electrical connections corroded from salt air and volcanic dust. Fuel pumps clogged from sediment in the napalm mixture. Ignition cylinders wore out faster than anticipated. Kissel and Patterson improvised solutions. They used telephone wire when standard electrical wire ran out. They fabricated replacement parts from damaged tank components. They kept all 8 flame tanks operational. The impact on Japanese defenses was measurable. 5th Marine Division reported that flame tanks had destroyed 43 fortified positions in 5 days. 4th Division reported similar numbers. Infantry casualties dropped 30% in sectors where flame tanks operated, compared to sectors without them. Marines were advancing faster, with fewer losses. Japanese defenders adapted their tactics. They concentrated anti-tank fire on flame tanks. They targeted fuel trucks supplying them. They attempted suicide attacks with magnetic charges. 3 flame tanks took damage from Japanese anti-tank guns, but armor held. None were destroyed. The CBH-1 systems survived impacts that would have disabled conventional equipment. On February 27th, Kissel was inside a flame tank when it took a direct hit from a Type 1 47mm anti-tank gun. The round struck the Sherman's frontal armor at an oblique angle and deflected. The impact threw Kissel against the hull interior. His shoulder dislocated. Patterson pulled him out of the tank and relocated the shoulder joint. Kissel was back working on electrical systems within 2 hours. What impressed Marine commanders was not just the weapon's effectiveness, but its reliability. The CBH-1 functioned in conditions that destroyed other equipment. Volcanic dust jammed machine guns and fouled engine carburetors. Salt spray corroded electrical systems. Constant vibration from rough terrain loosened everything. The flame tanks kept operating. Marine infantry developed new tactics around the flame tanks. Squads would advance behind the Shermans, using them as mobile cover. When the flame tank engaged a fortified position, infantry would rush forward during the confusion and secure the area. This coordinated approach reduced casualties while maintaining momentum. The statistics told the story. In the first week of flame tank operations, Marine divisions advanced 3 times faster than projections. Casualties from fortified positions dropped by 42%. Japanese defenders abandoned positions rather than face the flame tanks. Tunnel networks that would have taken weeks to clear were neutralized in days. But the human cost of operating these weapons was accumulating. Tank crews worked in extreme heat inside the Shermans. The CBH-1 system generated additional temperature from the pressurized fuel system. Crews suffered heat exhaustion. Some collapsed from dehydration. Kissel saw men pass out inside the tanks from temperatures exceeding 120 degrees. The flame tanks were working. They were saving Marine lives. They were changing the course of the battle. But the question remained whether 8 tanks and 2 Seabees could sustain this pace for however long Iwo Jima required to secure. March 1st marked 10 days of continuous flame tank operations. Kissel had been in combat for 20 consecutive days, sleeping 3 to 4 hours per night. His dislocated shoulder had not fully healed, but he continued working. Patterson showed signs of exhaustion, but refused evacuation. The 2 Seabees were the only personnel who fully understood the CBH-1 electrical systems. If they left, the flame tanks would eventually fail. The battle's intensity increased. Japanese defenders in the northern sector had fortified every ridge, ravine, and cave. This terrain favored defense. Volcanic rock provided natural cover. Interconnected tunnels allowed defenders to reappear in positions Marines thought were cleared. Casualties mounted. Progress slowed. 5th Marine Division commander specifically requested flame tanks for an area called the Meat Grinder. 3 fortified hills formed interlocking defensive positions. Hill 362, Turkey Knob, the amphitheater. Japanese defenders had held this sector for 9 days. Conventional attacks had failed. The division had lost over 800 Marines trying to take these positions. 4 flame tanks were assigned to support the assault on Hill 362. Kissel accompanied the lead tank. He had worked on this particular Sherman for 3 straight days, replacing corroded wiring and rebuilding the fuel pump. The electrical systems were functioning at peak efficiency. The tanks approached Hill 362 at 0800 hours on March 3rd. Japanese anti-tank fire was immediate and accurate. 1 Sherman took 3 hits on the turret, but armor held. The flame tanks continued advancing. At 100 yards from the first fortified position, all 4 opened fire simultaneously. 1,600 feet of flame engulfed the hillside. Cave entrances became infernos. Pillboxes burned. Japanese defenders attempting to evacuate through tunnel exits were caught in secondary fires. The assault lasted 12 minutes. When the flames stopped, Marines advanced and secured Hill 362 with minimal resistance. What had cost 800 casualties over 9 days was resolved in 12 minutes. Turkey Knob fell the same day using identical tactics. The amphitheater required 2 days, but flame tanks were decisive in both assaults. By March 5th, the Meat Grinder was secured. 5th Marine Division credited flame tanks with saving an estimated 500 Marine lives in that sector alone. The success brought increased demand. 3rd Marine Division, which had arrived as reinforcements, requested flame tanks for operations in the northern sector. But the 8 original tanks were reaching mechanical limits. Two had damaged fuel pumps that Patterson was struggling to repair with improvised parts. One had electrical failures that Kissel traced to corroded connections he could not fully replace. The tanks were operating at 75% capacity. Marine Corps leadership recognized the problem. A message went to Schofield Barracks requesting additional flame tanks and trained personnel. But Schofield was 4,000 miles away. Manufacturing and shipping would take weeks. The battle on Iwo Jima would not wait. Kissel understood the mathematics. 8 tanks, reduced capacity, increased demand. Northern sector still held thousands of Japanese defenders in fortified positions. The flame tanks had proven their worth. The question was whether they could sustain operations long enough to finish the battle. On March 7th, Japanese forces launched a rare counterattack in the northern sector. The flame tanks would face their most severe test. The Japanese counterattack began at 0200 hours on March 7th. 300 defenders emerged from tunnel networks in the northern sector and hit Marine positions near Katano Point. The assault was coordinated and violent. Marines called for immediate support. 2 flame tanks were dispatched in darkness. Night operations were dangerous for tanks. Limited visibility, difficult terrain. Japanese infantry could approach unseen with magnetic charges or satchel explosives. But Marine commanders considered the risk acceptable, given the flame tank's effectiveness. Kissel accompanied one of the tanks. He positioned himself in the assistant driver's seat, monitoring electrical systems by flashlight. The Sherman moved slowly through the darkness, guided by radio directions from forward observers. At 300 yards from the Marine lines, Japanese troops attacked the tank directly. Small arms fire hit the hull from multiple directions. Something heavy struck the turret, probably a satchel charge that failed to detonate. The driver kept moving forward. Kissel checked the CBH-1 pressure gauge. Still operational. The ignition system was functioning. At 150 yards from concentrated Japanese positions, the gunner fired. Flame illuminated the night. 400 feet of burning napalm swept across the hillside where Japanese troops had assembled. The effect was catastrophic for the attackers. Defenders caught in the open had no cover from the flame. The counterattack collapsed within minutes. The second flame tank arrived and finished securing the sector. By dawn on March 8th, the counterattack was defeated. Marines counted 187 Japanese dead in the sector. Marine casualties were 23, far lower than expected for a night engagement of that scale. The flame tanks had stopped a major assault that could have pushed Marine lines back significantly. But the overnight mission revealed serious problems. One flame tank's electrical system had multiple failures during the engagement. Kissel spent 6 hours tracing corroded connections and replacing damaged wiring. The second tank's fuel pump was failing completely. Patterson worked through the day attempting repairs with parts scavenged from damaged conventional Shermans. By evening, only 6 of the 8 flame tanks were operational. March 10th brought additional challenges. 5th Marine Division reported their flame tanks were consuming 10,000 gallons of fuel daily. The beach supply depot was struggling to produce enough napalm mixture. Fuel shortages forced rationing. Each tank was limited to 3 missions per day instead of 6. Effectiveness decreased proportionally. Kissel's physical condition deteriorated. 26 days of combat operations. Minimal sleep, poor nutrition. The dislocated shoulder caused constant pain. Patterson developed severe dehydration and heat exhaustion. A Navy corpsman ordered him to rest for 24 hours. That left Kissel as the only CB maintaining all operational flame tanks. He worked alone on March 11th, moving between tanks, repairing electrical systems, checking fuel lines, replacing ignition cylinders. His hands bled from cuts caused by sharp metal edges inside the cramped tank interiors. His uniform was soaked with sweat, fuel, and hydraulic fluid. He kept working. Marine commanders watching this 24-year-old electrician work himself to exhaustion understood something important. The flame tanks were not just machines. They were the product of human determination. Kissel had built them. He maintained them. He fought in them. His refusal to quit kept them operational. But even determination had limits. The battle was entering its 4th week. Japanese defenders still held strong positions. The question was whether Kissel and the flame tanks could last. March 12th brought reinforcements from Schofield Barracks. Not additional flame tanks, but replacement parts and 3 trained technicians who understood the CBH-1 systems. Patterson recovered enough to return to limited duty. Kissel finally had support. The operational tempo could be sustained. The final 2 weeks of the battle tested everything. Japanese defenders in the northern sector fought from prepared positions with no intention of surrender. Every cave required clearing. Every tunnel needed sealing. Every pillbox had to be destroyed. The flame tanks worked continuously. By March 20th, the 8 flame tanks had been in operation for 28 days. They had conducted over 240 missions. They had destroyed an estimated 370 fortified positions. They had consumed over 140,000 gallons of napalm fuel. Not one flame tank had been lost to enemy action. Not one crew had been killed while operating them. The comparison to portable flamethrowers was stark. Marine units using portable M22 flamethrowers suffered 92% casualties in one battalion. Flame tank crews suffered 12% casualties, mostly from shrapnel and concussion injuries. The difference was armor protection. The difference was Kissel's design. March 26, 1945, 36 days after the landing. Admiral Chester Nimitz declared Iwo Jima secure. Japanese resistance had collapsed. The surviving defenders retreated into caves, where they would eventually die or surrender. The Marine Corps had paid a terrible price. 6,821 killed, 19,217 wounded, over 26,000 casualties. More American casualties than Japanese for the only time in the Pacific War. But Marine commanders agreed on one point. The flame tanks had been the most effective weapon on the island. 4th Tank Battalion reported the flamethrower was probably the most valuable single weapon employed at Iwo Jima. 5th Marine Division stated the flamethrower tank was the most important single weapon available to this division. 23rd Regimental Combat Team reported highly successful and recommended more flame tanks per tank battalion. One Marine platoon leader wrote a simpler assessment. The infantry would sooner see one flamethrower tank than a dozen with 75s. That statement captured the reality. Marines trusted the flame tanks. They waited for them. They followed them into combat. The weapon Kissel had built saved thousands of Marine lives. Kissel worked on Iwo Jima for 32 days total. He accompanied flame tanks on over 20 combat missions. He maintained electrical systems under fire. He improvised repairs with limited resources. He refused evacuation despite injuries and exhaustion. His determination kept the flame tanks operational through the entire battle. The 8 flame tank crews received Presidential Unit citations with their respective tank battalions. Patterson received a Navy commendation for his technical work. Kissel received similar recognition. But the real recognition came from the Marines who fought behind those flame tanks and survived because of them. The question after Iwo Jima was whether the flame tanks would continue, whether the Marine Corps would adopt them permanently, whether Kissel's innovation would become standard doctrine or remain an isolated experiment. The answer would define how the military approached fortified positions for decades. The Marine Corps did not hesitate. Immediately after Iwo Jima, flame tanks became standard equipment for Pacific operations. For the invasion of Okinawa on April 1, 1945, the entire 713th Tank Battalion converted to flame, 54 tanks, all using systems based on Kissel's CBH-1 design. The CBs at Schofield Barracks supervised the conversion, training 3 officers and 60 enlisted men from the battalion. Okinawa proved the concept definitively. The flame tanks operated for 82 days. They consumed 200,000 gallons of napalm fuel. Army commanders stated the tanks had a psychological presence on the battlefield. United States troops preferred to follow them over standard armor for the fear they put in the enemy. Japanese defenders abandoned positions when flame tanks appeared. The weapon Kissel built at Schofield Barracks in late 1944 became the standard American approach to fortified positions. The impact extended beyond World War II. Flame tanks using CBH-1-derived systems saw action in Korea from 1950 to 1953. They remained in service until 1955, when superior models finally replaced them. For 11 years, Kissel's design was the primary flame tank in American service. The system he wired with 1,100 electrical connections in November 1944 influenced mechanized warfare doctrine for a generation. The statistics tell the story of lives saved. Portable flamethrower operators suffered 92% casualties on Iwo Jima. Flame tank crews suffered 12%. On Iwo Jima alone, flame tanks destroyed 370 fortified positions while protecting the Marines who advanced behind them. Casualties in sectors with flame tank support were 42% lower than sectors without them. 5th Marine Division estimated flame tanks saved 500 lives just in the meat grinder sector. The total number saved across the entire battle was likely thousands. Joseph Kissel returned to civilian life after the war. He had spent 32 days in combat on Iwo Jima. He had built a weapon that changed how the United States Marine Corps fought. He had maintained that weapon under fire. He had refused to quit when exhaustion and injury gave him every reason to evacuate. His determination kept 8 flame tanks operational through 36 days of the bloodiest battle in Marine Corps history. The legacy is simple but profound. A 24-year-old Navy electrician recognized that portable flamethrowers were killing their operators. He designed a better solution. He built it. He tested it in combat. He maintained it under the worst conditions imaginable. His innovation saved thousands of American lives and influenced military doctrine for decades. If this story moved you, please hit the like button. It helps others discover these accounts that deserve to be remembered. Subscribe to support our mission of preserving World War II history. Leave a comment telling us where you're watching from. We have viewers in over 70 countries. And if you'd like to share, tell us if anyone in your family served during the war. Whether in the Pacific, Europe, or on the home front, their service connects us all to this history. Thank you for learning about Electrician's mate 2nd Class Joseph Kissel and the weapon that changed Iwo Jima. Until the next story, remember those who serve.